In this lesson, we are going to learn about molar mass. And what is molar mass? Molar mass is the mass of 1 mole of the substance, exactly 1 mole. Because the definition has 2 different units, we can actually interpret into a conversion factor. We call that a molar mass conversion factor. Here I have 1 mole of a substance coming from this part right there. Then I have the number of mass, which is measured in grams. So I have 1 moles of A equal to the number of grams of A. But where do I get the number of grams from? And the beautiful part is that you can actually use the periodic table to get that number of grams. For example, if I look at carbon right here. So if I look at carbon, here I have 12.01. That is the atomic weight, but it's also the molar mass of carbon. That 12.01 is the molar mass of carbon. Being said, you can actually interpret that as 12.01 grams of carbon is equal to 1 mole of carbon. Or if I look at oxygen right here, that is the molar mass of oxygen. The substance is oxygen, and that is the mass. So we have 16.00 grams of oxygen equal to 1 mole of oxygen. In this case, the molar mass of carbon and oxygen are easy. We can just look at the periodic table to determine their molar mass. However, what happens when the substance A becomes extremely complicated, such as the one right here, 3Ca, parenthesis NO3, parenthesis 2. In order to solve for the molar mass of the substance, we need to know the different part of a chemical formula. First of all, there might be a number in front of a chemical formula. This is called the coefficient, and is indicating the amount of a specific substance. In this case, the 3 indicated are 3 moles of this substance or 3 of this substance. However, we only want 1 mole, so you can say that we can ignore the coefficient. But then we have the parentheses or parentheses. In this case, we have that parenthesis, that group NO3. And then we have the subscript. That subscript 2, 3, and so on. That subscript 2, 3 indicate the specific amount of an element or a polyatomic ions. For instance, if we look at the 3, that tells you there are 3 of O. But what about the Ca and the N? It doesn't have any subscript, so we know it's just going to be a 1. But what about this 2 right here? That 2 represents there are 2 of NO3. So before we can determine the molar mass of this whole entire substance, we have to list the element and count them. In this example, we have Ca, so we have 1 Ca, and then the N, we don't have just 1 N because that 2 right there making it, now there are 2 of nitrogen. Then we have the oxygen. Since there are 2 of 3 oxygen, that give us 6 oxygen total. So 6. To determine the total mass of all the elements in the chemical formula, we have to use the periodic tables. First of all, we have calcium, so we go find calciums, which we multiply by 40.08, because each one of them is 40.08. For nitrogen, it's 14.01. For oxygen, it's 16.0. Then we do the math behind it. We have 40.08, and this one we have 28.02, and this one we have 96.00. So these are the total mass of each element in the chemical formula based on how much of specific element that you have. And the last step is we add them all together. Give us 164.10. And this is the mass in grams. How do we express this as a conversion factor? Of course, we will have 1 mole of the substance. 1 mole, in this case, the substance is CaNO3. 2. Notice I don't care about the 3 because we are looking for 1 mole of a substance equal to 164.10 gram of CaNO3. 2. And this is a conversion factor that we can now apply to the stoichiometry flowchart. Let's try another one. Again, we can ignore the coefficient. In this case, we have Mg is just 1. Then Cl, in this case, because of that 2 right there, indicated our 2 of Cl, so we have 2 Cl. But what about the O? The oxygen, 2 of 3, that give us 6 oxygen. Now let's go find the total mass for each element. Mg, 24.31. Chlorine, 35.45. Oxygen, 16.0. And we use our calculator to multiply. We have 24.31 for the total mass of magnesium. For 5 for the total mass of chlorine. For oxygen, it would be 96.00 grams. So that's the total mass for oxygen because there are 6 of it. And then again, we find the total. And let's express this as a conversion factor. Let's try another problem. In this case, we have this chemical formula, parentheses NH4, parentheses 2O. So nitrogen, since there are 2 of one N, that gives us a total of 2 for nitrogen. And for hydrogen, there are 2 of 4 H, so that gives us a total of 8. And for oxygen, it's just 1 because it doesn't have any subscript. And we find the total mass for all the elements. Nitrogen is right here. So we time that 14.01 because each one is 14.01. And for hydrogen is 1.01. For oxygen again is 16.0. And we use our calculator to multiply it. We have 28.02. We have 8.08. And we have 16.00. And we add them all together. We have 52.10. And express this as a molar mass, we have 1 mole of this substance equal to 52.10 grams of this substance. Lastly, let's try this problem. We have 5 CaCO3 or 5 calcium carbonate, which we will ignore the 5 because it is the coefficient and we are only looking for 1 mole. We're not looking for 5 mole. Molar mass is about 1 mole. So we ignore the 5. And then we can list the elements. So calcium doesn't have any subscript, so it's going to be 1. Carbon will be just 1 as well. And then oxygen is 3. Then we find the mass. Calcium on the periodic table, 40.08. Carbon is 12.01. And oxygen is 16.00. And let's calculate for the total mass. So here we have calcium. The total mass of calcium in this substance is 40.08, for carbon is 12.01, and for oxygen is 48.00 because there are 3 of it. And we add them together, we have 100.09. And to express this as a molar mass, we have 1 mole of CaCO3 equal to 100.09 grams of CaCO3. And there you go. That is our molar mass.